Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Okay, my name is Muhammad Saiful Azani. My student ID is CB19073. Okay, so I'm here gonna explain the assignment of individual video, which is part B. Okay, so we're gonna start the first question. Okay, the first question is, let X be the last digit of 33,333, power of 55,555, and Y be the last digit of 77,777, power of 99,999. Okay, so we need to find the least common factor, which is LCM, between X and Y by using prime factorization method. Okay, so firstly, we need to find the X and Y. Okay, we know that X is the last digit of 33,333, power of 55,555, while Y is the last digit of 77,777, power of 99,999. Okay, so how to find the last digit? So we need to use the second method. We need to find the what iteration to complete the first cycle. Okay, so as I written here that we need to start with first iteration, which is 3 power of 1. So 3 power of 1 is 3, 3 power of 2 is 9, 3 power of 3 is 37, 3 power of 4 is 81, 3 power of 5 is 243. When we arrive at the fifth iteration, we can see that it's already repeat the second cycle. So we can see that fourth iteration is the gonna complete the first cycle, which is 1. So how to how to find the X? So you can see that the the power of X is 55,555. So we're gonna divide by 4, which is fourth iteration, because it complete the first cycle. We get 13,888.75, but this is not the real answer. But so we need to find the remainder actually to get the iteration number. So how to get iteration number? So it state that we need to minus and using some multiplication and minus. So we can get the answer is 3, which is third iteration. So we can conclude that the third iteration, the last digit is 7. So we can conclude that X is 7. So we proceed to the Y. Okay, so how to find Y? So we use the same method. Okay, first 7 power of 1 is 7, 7 power of 2 is 49, 7 power of 3 is 343, 7 power of 4 is 2,401, 7 power of 5 is 16,807. So we can see that at the fifth iteration is repeated for the second cycle. So we can assume that fourth iteration is gonna complete the first cycle. Okay, so as usual, we can get the power of we need to take the power of Y, which is 99,999, divided by 4, which is fourth iteration. We get 24,999.75, but this is not the answer too. So we need to get the R. So using multiplication and minus operation, we get it third iteration also. So when we refer to third iteration, which is the last digit is 3, so we can assume that Y is equals to 3. So we already get the X and Y, so we need to find the lowest common multiple, which we using by prime factorization method. So we use LCM, which is X and Y. We get 7 and 3. So by 3 we can get 3 power of 1 and 7 power of 0, while 7 is 3 power of 0 and 7 power of 1. So by using LCM method, we can get that 7 max of a 0 and 1, which is we take as 1, and while 3 max 1 0, which is we take 1 also. So 7 power of 1 times 3 power of 1, we can get 21. Okay. So we're gonna proceed to question 2, which is about set function and relations. Okay, so the question is, let A set A, which is we got 1 2 3 and 4. So we need to find the relation on A, which is symmetric and transitive but not reflexive. So we're gonna look at the answers. Okay, so we got set A, which is we got 1 2 3 and 4. So we need to find the relation which is symmetric and transitive but not reflexive. Okay, we know that relation is from A to A. So the number of element in A is 4, which is 1 2 3 and 4. So the total order pair is A times A, which is 4 times 4 is 16. So the order pair for the set A is 16. Okay, we can see that order pair is 1 1 1 2 1 3 1 4 until 4 4. Okay, so firstly we need to find the terms. I'm gonna explain about the reflexive. Okay, reflexive means there is an ordered pair of the same elements for all the elements. So we can state that R1 equals to 1 1 2 2 3 3 and 4 4, which is same elements. Okay, done for reflexive. We're gonna go for the symmetric. Okay, symmetric, this is a symmetric which is inverse of the element for the all order pair. So we can see that is 1 1 1 2 2 1 until 4 4. So for the transitive, we can transitive relation using the ordered pair such that A goes to B, A related to B and B related to C. Okay, so right here I'm list down the ratio between A and B, which is 1 1 until 4 4, while for B and C also the same, 1 1 until 4 4, while A and C is also same, 1 1 until 4 4. So we can conclude that for the transitive we can conclude that the transitive is 1 2 1 3 1 4 until 4 4. It's also got 1 and 1. Okay, so the conclusion is to get the symmetric and transitive but not reflexive. So we can get the answer is 1 2 2 1 1 3 3 1 1 4 4 1 2 3 3 2 2 4 4 2 3 4 and 4 3. We can see that R4 equals to R2 and R3, which is R2 is we can see that R2 is for symmetry, while R3 equals to transitive, but not R1 because R1 is the reflexive. Okay, we proceed to the question 3. It's about logic. So the question is, Leong and Hafiz witnessed a bank robbery. At trial, Leong testified that Botak did not enter the bank, and if Chin put a gun, then Amir collected the money. This is for the Leong statement. While on the other hand, Hafiz testified that if Chin did not pull the gun, then Botak did enter the bank and Amir collected the money. This is for the Hafiz statement. So the question is if it is possible for the witness to tell the truth, and will the criminal be convicted. Okay, so we're gonna make some statement, which is A, Amir which collected the money, while Botak entered the bank, and C, Chin pulled the gun. So we're gonna do truth table for the two statement, which is Leong statement and Hafiz statement. So for the Leong statement, we're gonna do as usual for the Amir, Botak and chain statement. Then next we're gonna do the inverse of botak, which is do not enter the bank. So inverse of botak did enter the bank. So the next statement is about botak did not enter the bank and Chin pulled the gun. Okay, so then we're gonna make Amir collected the money, and we got the bracket of botak did not enter the bank and Chin pulled the gun. Okay, so we're gonna combine from the Leon statement that this is a one true, which is botak did not enter the bank and Chin pulled the gun is true, and botak did not enter the bank also true, and Amir collected the money, and the bracket botak did not enter the bank while Chin pulled the gun is true also. So we can conclude that the Leon statement conclude that Leon is telling the truth. Okay, so for the Hafiz statement, we can say that do as usual for the Amir collected the money, botak into the bank, as Chin pulled the gun. Okay, so we're gonna make inverse of Chin did not pull the gun. So the next statement is B, which is botak into the bank and Amir collected the money. And the last one is if Chin did not pull a gun and botak did enter bank and Chin pulled the gun. Okay, so we can say that when if Chin did not pull the gun, so which is true, then botak did enter the bank and Amir collected the money, which is true also. So the last statement, which Chin did not pull the gun and botak enter the bank and Chin pull the gun also is true. So we conclude that Hafiz statement, which is Hafiz is telling the truth also. Okay, so as a conclusion that based on the both truth table, state that it is possible for the both witnesses is telling the truth and the criminal will be convicted. We proceed to the question 4. It's about the proof technique. Okay, so let A modulo N congruence relation. So by using any valid proof method, proof if A congruence X modulus N and B congruence Y modulus N. Okay, so there's a two different question. So we can so we're gonna proceed with first question first. It's about A plus B congruence X plus Y modulus N. So firstly we're gonna write A congruence X mod N and B congruence Y mod N. So the question is A plus B congruence X plus Y modulus N. So we're gonna split into two, which A congruence mod N and B congruence Y mod N. Okay, so by using definition of mode, we can turn into A minus X equals to N times K1. So this is the first statement. K1 is equals to any real number. Okay, for the next one is B congruent Y mod N. By using definition of mode, you can get B minus Y equals to N K2 equals to statement 2. We can state that K2 is equals to any real number. So by using addition of 1 and statement 1 and 2, we can get A minus X plus B minus Y equals to N K1 plus N K2. So we're gonna separate between A and B. minus x plus y equals to n. We're gonna factorize it, which is n k1 plus k2. So next we're gonna get a plus b minus x plus y equals to nk, which is k equals to k1 plus k2 equals to k. So in the conclusion, we can get using by definition, we can get a plus b congruence x plus y modulus n. For the question 2, which is AB congruence xy modulus n. So we're gonna write the same thing, which is A congruent x mod n and B congruence y mod n. Okay, so the question is AB congruence xy mod n. So we're gonna do the same thing, which is we're gonna split A congruence x mod n by using definition of mode. We can get A minus x equals to nk1. So k1 is also the real number. So we're gonna multiply this statement A by B. So we're gonna get AB minus BX equals to nk1B. So for the B congruence y mod n, so by using definition of mode, B minus y equals to nk2, which is k2 equals to any real number also. So multiply statement B, which is B minus y equals to nk2 by x. So we're gonna get bx minus xy equals to nk2x. So we're gonna using addition method. So AB minus bx plus bx minus xy equals to nk1b plus nk2x. So we're gonna eliminate b minus bx and plus bx. So we're gonna get AB minus xy equals to n. We factorize the k, which is k1 plus k1b plus k2x. So we're gonna separate it into two back, which is AB minus xy equals to nk and k equals to k1b plus k2x. So by using the definition, we can get AB congruence xy mod n. Okay, we proceed to question 5, abstract algebra. We can see that G, there's a 4 element, which is AB, A minus B, 0 and A plus B. We can see that AB equals to any real number under addition. So we need to determine whether G is an abelian group. Okay, so firstly, we're gonna write the question first. So AB, A minus B, 0 and A plus B. So the G is under addition. So firstly we're gonna do the closed one. So we can get A1 B1 A1 minus B1 0 and A1 plus B1 plus A2 B2 A2 minus B2 0 and A2 plus B2. We can get A1 B1 plus A2 B2 while A2 and B2 plus A1 minus B1 and 0, and the last one is A1 plus B1 plus A2 plus B2. So we can get we can assume that A1 and B1 and A2 and B2 is a real number. So we can for the C, we can get equals to A3 B3 and A3 minus B3 0 and A3 plus B3. So A3 B3 also we can assume is a real number. So we can conclude that C equals to G. So G is closed. So we're gonna do the next one is associative. So we're gonna add A1 B1 A1 minus B1 0 and A1 plus B1 plus A2 B2 minus B2 0 and A2 plus B2 plus A3 B3, A3 minus B3 0, and A3 plus B3 equals to A4 B4, A4 minus B4 0, and A4 plus B4. So the next one is A1 B1, A1 minus B1 0, and A1 plus B1 plus bracket of A2 B2, A2 minus B2 0, A2 B2 plus B2 plus A3 B3, A3 B minus B3 0, A3 plus B3 equals to A4 B4, A4 minus B4 0, A4 plus B4. So we can conclude that A1 B1, A1 minus B1 0, A1 plus B1, A2 B2, A2 minus B2 0, A2 plus B2 plus A3 B3, A3 minus B3 0, A3 plus B3 equals to A1 B1, A1 minus B1 0, A1 plus B1 plus bracket of A2 B2, A2 minus B2 0, A2 plus B2 plus A3 B3, A3 minus B3 0, A3 plus B3 also equals each other. So we can conclude that G is associative. So the next one, we're gonna go for the identity. So identity is AB minus A minus B 0, A plus B plus E1 E2 A3 E4 equals to E1 E2 A3 E4 plus AB A minus B 0, A plus B equals to AB A minus B 0, A plus B. So which E equals to 0 0 0 0. You can conclude that for the G under the addition, E equals to 0 0 0 0. So it is the identity. So the second last is the inverse. So AB A minus B 0, A plus B plus AB A minus B 0, A plus B inverse, we can get 0 0 0 0. So if we inverse the G, so we can get negative AB, negative A minus B 0, negative A plus B equals to the real number. So we can get that G inverse for the G times G inverse is equals to negative AB, negative A minus B 0, negative A plus B. So the last one is cumulative. So A1 B1, A1 minus B1 0, A1 plus B1 plus A2 B2, A2 minus B2 0, A plus 2, A2 plus B2 equals to A3 B3, A3 minus B3 0, A3 plus B3. So the next one is A2 B2, A2 minus B2 0, A2 plus B2 plus A1 B1, A1 minus B1 0, A1 plus B1 equals to A3 B3, A3 minus B3 0, A3 plus B3. So we can get the same answer. So we can conclude that A1 B1, A1 minus B1 0, A1 minus A1 plus B1 plus A2 B2, A2 minus B2 0, A2 plus B2 is equal to A2 B2, A2 minus B2 0, A2 plus B2 plus A1 B1, A1 minus B1 0, A1 plus B1. So we can conclude that G is also cumulative. So we can prove that G under the addition is an abelian group.